The fair warning on these, we're only doing 2. They are not short. Write small. Okay? When you get to the 2 problems here. All right, we've seen a similar process like to what we're going to do today before. Okay? But we're going to kind of refine that a little bit and add this complex pairs theorem into it. So basically what this is saying is if I have a plus bi as a 0, a minus bi is also a 0. And we saw that happening yesterday. 5i was it, negative 5i was also part of it. Okay? So that's actually a thing. It does happen like that every time. Okay? So if you have one imaginary number, you always have a second one. All right, so let's talk about this. We're going to work backwards. We're going to try to get back to the polynomial with these zeros. Here's the thing, though. What else do I have? If I have 2 plus 5i, I also have what?
2 minus 5i.
Yep. So I actually have 4 zeros. Notice one of them is repeated, isn't it?
Yeah.
All right, so the way we work backwards, and we've done this process before, is we set them all equal to x.
Whoa.
Oops. X equals 2 plus 5i. Now we're going to turn them all into linear factors, just like we were doing yesterday. Okay? So how do I move the 1? Add it. So x plus 1 equals 0, and another x plus 1. I don't know why I put parentheses around it. I don't need them yet. Okay. All right, and then how do we move the 2?
Subtract.
Good. And how do we move that first 5i?
Subtract.
Again, we subtract the 2. And then how do I move the second 5i?
Add.
Okay. Make sure you get it all written. All right, the next thing I got to do is multiply all of those together. So I've got to multiply x plus 1 times x plus 1, and x minus 2 minus 5i, and x minus 2 plus 5i. I don't really need the equal to 0 part anymore because we're just trying to find the polynomial. All right, so we're going to do this in stages. All right? We're going to end up having to do 2 multiplication boxes by the end. So this here, not too bad to FOIL it, right? So what's x times x?
X squared.
Good. And then I'd have x times 1 is x, and x times 1 is x, so how many x's do I have? 2x, and then 1 times 1 is 1. All right, so I've got the front part done. I'm also going to try to do the back part. Remember how we pulled out a 3x3 box? We're going to do that again, but we're going to do it twice in this problem. So think about that in relation to the space you have. You're going to have to do a second box somewhere, okay? So minus 2 minus 5i, and then x minus 2 plus 5i. All right, just start cranking through it. So what's x times x?
X squared.
Good. X times negative 2i.
And negative 2xi.
There you go. Okay. Eventually our goal here is to get the i's to go away, right? So we should have them canceling somewhere. X times negative 5.
I think an I on the second.
I don't know how I got an I in the second one. Thank you. I wrote it down and shouldn't have. So you guys got to catch me on a Friday here. All right. Let's get rid of that I. We good? All right. X times negative 5i would be negative.
5xi.
There we go. Negative 2 times x is.
Negative 2.
Good. Negative 2 times negative 2 is
4.
4. Negative 2 times negative 5i is 10i. 5i times x is
5xi.
good. 5i times negative 2 is
Negative 10i.
good. And 5i times negative 5i is
Negative 25i squared.
better known as
25.
25. All right, let's talk about the canceling piece. So I'm going to start canceling stuff. What goes away in the box?
Negative 10i and 10i. And then positive 5xi and negative 5xi.
Good.
And then
All right, so then let's talk about these guys are like terms and these two are like terms, right?
Yeah.
So I'm going to combine my like terms together. So I've got x squared minus what?
4x
4x plus,
29.
good. All right, guess what? We've got another 3 times 3, right? Again, it's not hard. This is a tedious thing, right? We know how to do all of these steps. We've done them all before, just not as long. So I'm going to put my x squared plus 2x plus 1 on the top and x squared minus 4x plus 29 down the side. All right, so x squared times x squared is?
X to the 4.
Good. X squared times 2x is?
2x cubed.
X squared times 1?
X squared.
X squared times negative 4x?
Negative 4 cubed.
Negative 4x times 2x?
Negative 8 squared.
Negative 4x times 1?
Negative 4x.
Good. 29 times x squared?
29x
29.
squared.
Good. 29 times 2x?
58 x.
29 times 1. All right, now look at this one. This one's different, right? But that thing with the diagonals still works. Do you see the like terms on the diagonals?
Yeah.
Okay, so let's add our like terms together. So I've got x fourth just by himself. What do we get for the cubes?
2x cubed.
Good. And then for the squareds, you all have a calculator if you need it.
29.
It is 20 something.
22. 22x.
Good. And then for my x's,
29. Oh, no, just kidding.
54.
plus the 29 at the end. Not pretty at all, right? Tedious. Not hard, tedious. Okay. All right, we're going to do only one more. Aren't you glad about that? Yeah. So and then you get some work time and some stamping time today. Okay. So it says use the given 0 to find all the zeros of the function. This one's going to be a little bit different the way we work it. Because they gave us an imaginary 0. What other 0 do we get for free?
The positive.
Yeah, x. So that conjugate. So before I try to do anything, I'm going to try to get those kind of foiled and factored out. So I'm going to write my linear pairs. So I know x equals 1 minus 3i and x equals 1 plus 3i. How do we move the 1?
Subtract.
Good. And how do I move the 3i? Good. And then how do I move this one? Subtract. And how do I move that 3i? Good. Now we're going to drop the equals 0 and go x minus 1 plus 3i, x minus 1 minus 3i. Let me make that look right. It says 3i. Okay. What do you think I need to do from there? Make a box. Okay, let's get out the box. The 3 by 3 box. Good news, we only have to do one 3 by 3 box this time. No, we aren't doing a 5 by 5. Okay. You want to do a 5 by 5? Next week on the performance task. Okay. All right. Depends on how you get to make your own function for the performance task. So, all right. So x times x is what?
X squared.
Good. X times negative 1.
Negative x.
Negative x. X times 3i.
3xi.
Good. Negative 1 times x.
Negative x.
Good. Negative 1 times negative 1.
1.
1. Negative 1 times 3i.
Negative 3i.
X times negative 3i.
Negative 3i xi.
Negative 3i times negative 1.
3i.
And negative 3i times 3i.
Negative 9.
I squared.
Better known as 9. Same pattern on this box, right?
Yeah.
That we saw before with the other i's. So the 3xi goes, the 3i goes, and then you have your diagonals that match. So let's combine our like terms there. So we get x squared
Minus x.
minus 2x plus what?
10.
All right, that's great. We need to find all the zeros of the function. We know those two, but why did we do all of this? I don't know what happened there. Jeez. All right. I still need to factor those out of this thing, don't I?
Yeah.
So I'm going to use long division to do that, because it's the only way I can get them factored out. So here's where long division comes into play and is useful. All right. I did say we weren't going to do another one of those boxes on this problem. I didn't mention that we were also going to do long division, right? I was saving that surprise for the end. Okay, wasn't that nice? All right, so let's see what happens. So x squared goes into x to the fourth how many times? X squared. Good. So now you're going to distribute this through. So x squared times x squared is?
X to the fourth.
Good. X squared times negative 2x?
2x.
Good. X squared times 10?
Plus 10x squared.
Good. What are we supposed to do to the signs? Change them. So negative, positive, negative. The fourths are gone. Negative 3x cubed and positive 2x cubed.
X cubed.
Negative x cubed. It's 6x squared, negative 10x squared. Good. And I'm going to drop down 2x and negative 60 so I don't lose them. Okay. How many times does x squared go into negative x cubed? Negative x times. So I'm going to distribute that. So I get negative x cubed. What's negative x times negative 2x?
Positive 4x squared.
Positive 2x squared. All right, negative x times 10 is? Good. All right, I'm going to do what to all the signs?
Switch.
Switch them. So plus, minus, plus. The cubes go. What's negative 4x squared, negative 2x squared?
Negative 6x squared.
Negative 6x squared. 2x and 10x is?
12x.
And then drop down the negative 60. All right, how many times does x squared divide negative 6x squared? Negative 6, right?
Yeah.
Distribute. I should get the same thing, right? Because this is supposed to be a 0. So negative 6 times x squared would be negative 6x squared. Negative 6 times negative 2x is?
Positive
12x.
12x. Sorry, I'm writing over the top. Negative 6 times 10 is?
Negative 60.
And what are you supposed to do to all the signs? Change them. Do I really need to do that? What's going to happen?
It's always good to know.
It's going to cancel, right? So remainder 0. So this is what we're working with. Have I found the zeros yet? No. What do I need to do? I know that these are 2 of the zeros, right? So how do I get the other zeros based on this? Let's hope a magic X works, right? Let's hope. If not, there's more imaginaries, right? All right, so 2 numbers that multiply to negative 6 and add to negative 1. Good. So we have, I'm going to go right to zero product property. X plus 2 equals 0. X minus 3 equals 0. So what are the other 2 zeros?
X equals negative 2 and x equals positive 3.
Good. So if you wanted to make a list of your zeros, these would be included in it, along with what, 1 plus or minus 3i would also be in there.
Yeah.
Okay, again, it's not that each little individual part is hard. It's a tedious, long process, which is why we're doing like I think every other odd again, and you're getting double homework points for it. Okay, so everybody look in haiku. Okay, that took longer than I